All right, if we look at our next example, the graph paper is just like scratch paper for us. And so I'm going to use this scratch paper, but you have to kind of plan ahead of where you're going to go. So the pirate is pacing 5 meters at 20 degrees north of east, and then 9 meters west, and then 7 meters at 40 degrees south of west. So what is her displacement from the starting position? And just because there's so many directions going on, I'm going to start here. And let's say this is the starting point. So my pirate is going to start here. And she is going to pace 5 meters at 20 degrees north of east. And so I'm just going to make a line at approximately 20 degrees, and it's going to be approximately 5 meters long. And then I'm going to go from there. All right, so my pirate is going 5 meters at 20 degrees north of east, and then 9 meters to the west, and then she is going to go 7 meters at 40 degrees south of west. And I'm trying to draw my vectors as close to scale as possible, but since I don't know the exact numbers of these, it's kind of hard. But it is going to look something like this. And then the question is, what is her displacement from her starting position? So now we need to find that displacement vector there at the end. All right, I'm going to call my first vector vector A, vector B, and then vector C. And then our resultant vector, and I'm going to call that R for resultant vector. I'm going to zoom in so that we can see this better because we need to put our degrees and we need to start breaking up into components. Okay, these two vectors, vector A and vector C, because they are not straight across or straight up and down, they have a degree associated with them. We have to break them up into components, the X component and the Y component. And so I'm calling this X sub A because it goes with this vector A, and Y sub A because it goes with vector A. This one I'm calling X sub C and Y sub C. And I put the 20 degrees in here, and I believe the 40 degree goes here. And I actually think that's wrong. Because of the explanation, it says 40 degrees south of west. So 40 degrees south of west, I believe means the 40 should be going here, which means this is a 50. So I'm going to change that to a 50 degree. Okay, so now we need to find out the length of each of those, X sub A, Y sub A, X sub C, and Y sub C. Add that to the B because it is straight west, so that's just X only, and find out what that is for the resultant. All right, we need to go back to our SOHCAHTOA. So if I pay attention to this little triangle over here, if I said the sine of 20 is opposite over hypotenuse, that is going to be Y sub A over, and the hypotenuse here was 5 meters. I didn't write that in, but that is 5 meters. Now, if we are solving for Y sub A, which is what we need to do, then we can multiply both sides by 5 meters. And so we get 5 meters times the sine of 20 is equal to Y sub A. And that's what we need. Also, if we looked at the cosine of 20, cosine is adjacent over hypotenuse. That's going to be X sub A over 5 meters. So if we multiply both sides by 5 meters, we get 5 meters times the cosine of 20 is equal to X sub A. All right, that's what I'm going to put over here. If you just want to leave it here, that's fine. But what I'm going to say is X sub A is 5 meters times the sine of 20. And Y sub A is 5 meters times the cosine of 20. Now I'm going to go to my calculator. I'm going to multiply those out and see what I get. All right, I'm getting 4.70 for X sub A and 1.71 for Y sub A. And I need to think, are those positive or negative? I'm going to call to the right positive, or in other words, east. I'm going to call to the left or the west negative. I'm going to call down south in the negative. I'm going to call up plus or and north. So in this case, this first vector, it is going positive and positive. These are both positive values. And I'm just going to want to pay attention to that as I go. All right, the next one I'm going to take a look at is B. Well, that's easy. X sub B, we already know. It is 9 meters. And Y sub B is 0 meters. It didn't go anywhere in that direction. All right, now we need to talk about C. X sub C and y sub c. And similar is, we're going to do just similar to what we did before. We're going to say, all right, the sine of, well, I'm going to stick with 50 over here. So the sine of 50 is x over 7. So 7 times the sine of 50 is going to be x sub c, and 7 times the cosine of 50 is going to be y sub c. So now I'm going to do it with my calculator. I'm going to make those calculations. Okay, so I get 5.36 meters and 4.50 meters. I need to look at positive or negative. It is negative because it's going to the west, so my x is a negative. It's also going down or south, so that's also negative. So both of those are negative. Now what I need to do is I need to add up all these together in the x direction and then add up all the rest of them in the y direction. All right, so I'm going to add up all three of my x components, and I get 4.70 plus 9 plus a negative 5.36. I'm going to put that on my calculator. So I get my x total is 8.34 meters. Okay, I made a mistake on my adding up my x components. This 9 should be a negative 9, right? It's going to the west. So I need to redo that calculation. So that's going to be negative 9.66 meters. I need to do the same thing for my y's. So my total in the y direction is negative 2.79 meters. Okay, so now we're ready to deal with our resultant vector. So now I need to figure out what this resultant vector is. I need to do Pythagorean theorem with negative 9.66 and a negative 2.79. So I'm going to use those numbers for my Pythagorean theorem. All right, and I'm getting my resultant vector length is going to be 10.05. Rather than having a negative, we'll have the direction with the angle that we choose. So I'm going to hold off on negatives. Just 10.05 meters. And again, just double checking on our grid. I was saying that each box is 1 because we went over 5 and then we went back 9. So if each box is 1 and that's almost to 9 and it's at an angle, I think actually we did a pretty good job of drawing them to scale, and the 10.05 does fit that scale. So resultant vector is 10.05 meters. We now have to do the inverse tangent to find the angle. And so once again, I'm going to be using these two numbers, 9.66 and 2.79. So when I do my inverse tangent, I get 73.9 degrees. The angle that I was paying attention to is the one, I was calling this my theta. Let me try again. This right here, I was calling this my theta. It might actually make more sense to call this angle up here, like to end our answer. So let me subtract that from 90. And when I subtract that from 90, I get 16 degrees. I'm going to say, I'm taking up a lot of space here. My final answer. All right, my final answer is here. My resultant vector is 10.05 meters at 16.1 degrees south of west. Because if it was due west, it would be going here. It's a little bit south of that, 16.1 degrees south of west. All right, we will continue to work on vectors all year long, but we'll do some practice in class next time.